K6ST Barry for the SNARS monthly meeting. This is in November 6th, 2021. This is the third portion. This is the general Q&A. So we have some space to ask Rudy more details, and we'll get your voices in here too about the Nano VNA. If you have questions about SNARS or other ham radio things not related to today's presentation, you can ask it also. Rudy just put in the text in the chat his email address. If you want to get hold of him, it's Rudy, RUDI at WIEDEMANN.cc. Or if you have difficulty with that, just send an email to myself, Barry, and the email address is Kilo 6 Sierra Tango. That's K6ST at ARRL.net. Okay, let's get some voices on here. Let's start with Jim. Hey, Jim, go ahead and ask your question. Unmute yourself.
So I just wanted to clarify on the antenna plane. You had pointed to the current choke. It just wasn't clear exactly which point you were talking about measuring. Are you talking about removing the current choke and measuring at that SO connector, or I wasn't completely clear on what you were saying there.
So let me do something here. Now that we've ended the formal part of this, I'm going to move this camera around. Can you see, Barry, can you see my PC camera?
I have to flip it around. Just hang on 1 second.
What I'm going to show you is the base of the screwdriver antenna.
Spotlight. Hang on 1 sec, Rudy. Let me get it over to your other. Okay, we can see it now.
Okay.
Although it's a little bit dark. Oh, there we go. Yeah, we can see it now.
So here by my pinky is the coax coming in from the Nano VNA. And up at the top is what I plug in right here. I'm just trying to look at where I'm looking at here. Okay. It's a little bit, oh yeah, hang on a second. Let me get a little light on the subject. Stand by. I have a mess for a desk here. As you can imagine, it's just a ton of crap sitting here. So let's see here. All right, so there's the base. There's the SO239 at the base of the screwdriver antenna right here, okay? And that's where I literally plug this in with a male-male adapter. And inside here, right at the antenna, is a current choke. And that's what I've built into here. I've also built a little up-down reverser for the polarity on my Anderson power poles here for powering up the screwdriver antenna up or down. And for those of you who have not heard about Anderson power poles, I swear by them. These are the greatest things since sliced bread. This is the best connector, way better than Molex. These are sexless. You can plug them in blindfolded. You can't get it wrong. They're polarized. And just remember, red roof. And you'll see that the flat part is at the roof on the right. That's the red, that's the positive. And that's the convention. And as long as you follow that convention, you can't get it wrong. You'll plug into anybody's pair of Anderson power poles and be compatible. And you can plug it in blindfolded, like I said. And it's very, handles a lot of current. These little guys can easily handle 30 amps. And they have them up to like, I think 70 or 100 amps for bigger ones. So that's what I use here to drive it. So hopefully that explains what we're talking about. And so the calibration plane would be right here. I would put my calibrators right here, my open, my short, and my load right here at the right there on the SO239.
So you're saying you would put with an adapter, you put the calibration pieces at the far end of your choke, right? Is there any coax between that choke and the antenna?
Nope. There's an adapter right there.
Okay.
Okay. There's a little PL259 to PL259 adapter right here, and that's what I literally had this screwed in right in here.
And if you had a coax between the choke and the antenna, you would include that coax in the calibration, is what you're saying?
Absolutely. So
okay.
The whole idea is you want to see exactly what the actual antenna, the business end of the antenna, is actually seeing. That's where you want to calibrate your Nano VNA, your system, including the cable from the Nano VNA to that calibration plane, chokes, balance, all of that stuff in between. That's the right way to do it.
Okay, thank you.
Okay, thanks. Thanks. I'm going to make this simple. We've got 25 people. People can unmute themselves, but do me a favor. When you unmute yourself to ask a question, give your call sign. Let's acknowledge you so we don't get a pile up. Who else would like to ask a question of Rudy about Nano VNA, or if you have other questions about SNARS or general ham radio, just give your call sign.
KG7 QXE.
Aha, KG7QXC, you're on. Go ahead, Wes.
Okay, thank you. Rudy.
Yes.
At VNA, here's what I got. I'm going to take the camera off my computer. I'm going to swing it around here and show you what I got.
Hold on. I have to take something off so we can see you. Go ahead, Wes.
Okay. Anyway, I'll get it on here. Okay. As you can see, I have a antenna tuner. It's a LDG 600 Pro 2 auto.
Yep.
As you can see, I also have controls, capacitance, and inductance.
Yes.
How would that VNA, how would I be able to utilize that with this?
That's a great question. That's the latest version of the software the firmware update to this little dash FV2 actually gives you the solution, the LC solution of the network for an L network, 4 ways, right? With the capacitor, high pass, low pass, and capacitor towards the rig, or capacitor towards the antenna, and it actually gives you the readout. Hang on a second, and I can, if you got a moment, I can actually plug this antenna back in and actually show it to you.
Okay.
Flip it over to your VNA screen, Rudy. Just hang on one sec. Let me get to your cell one. Okay, so now we're on your VNA screen. Go ahead, Rudy.
Yep, so I'm screwing that balun, excuse me, not balun, but a current choke. There's no balun in here. I'm screwing the current choke back into the antenna at the base, and I'm trying to get it lined up here. Hold on. All right, here we go.
Also, when you're done doing that and you come back, scoot the VNA up a little bit. We can see your cell phone reflection in there a little.
Yep.
Okay, perfect. Yeah, I'll bring it down a little. There we go. Good. Yeah, perfect.
You got the sweet spot. Okay, so let me hang on a second. Let me plug this thing back in. Where is that? That's going here. Hang on, I've got too many cables on this bloody table here. Okay, that's going, all right. And I all I gotta do is plug that back into the antenna. And now I've got control of the antenna. Okay, great. So what we're gonna do is show you that this actually gives you an analysis, okay? So I've got my auto tracking here. So I've got the minimum SWR 1.01. Look at the 50.7 ohms, almost perfect 50 ohm match. So what I'm gonna do is, let's see, where is it? Under config, on the top menu is called the config choice on the top menu. You see it says LC match. Check what happens now. Look at this. LC match for a source of 50 ohms. No need for an LC match because it's resonant. Okay. Yeah. But let me try screwing it up. Literally. It's a screwdriver antenna, so I'm going to screw it up. Let's go up in frequency. No. Better yet, let's go down in frequency, because this is a short antenna and it's going to get tougher and tougher. As I raise this coil and add more turns to this screwdriver antenna system, I'm increasing the impedance and it's going to take progressively more coil turns to get an extra number of megahertz down in my bandwidth. So I'm probably already off of my 15 megahertz. So let me just change the range. Okay. Let me go back to, let me do a recall of my 3 to 30 megahertz scan. All right. So there's my 3 to 30 megahertz scan. All right. So the one, this is, ignore this big fat one. That's bogus data. The one you really want is this sharp one down here that's sitting at around 10 megahertz right now. And if I turn off the Smith chart, one of the things I learned is if you turn off the Smith chart trace, then the auto tracking will work. I don't know why they do it. I think they just don't know which one to track. So I go to marker, search, minimum tracking is on. And so it should find, oh, it's finding the bogus one. Let's just change the stimulus range to a stop of, say, 10 megahertz. And that'll get rid of this upper trace and it'll expand the lower trace here.
Yeah.
Okay, so here we are. We've got, let me continue going down in frequency. All right, so now the trace we're looking at is right here. It just came down off of 10 megahertz and it's coming down. Can you see how that's moving?
Yeah.
Now, it's a lot of noise on here because a motor generates a crap load of noise. But let me stop the motor. And now it'll settle out. And now we can see it sitting here at 9.23 megahertz. But now I just added about 3 or 4 inches on this coil just to get down from 20 meters down below 30 meters. But we can see it moving. And it's moving, it's moving. I've got maybe 4 inches left of coil. So I can't quite get down to 40 meters. I'm sitting at 8 megahertz now. All right, so now you can see my SWR is about 2.72. Whoops, hang on a second, my antenna's tipping over. So SWR is sitting at about 1.8, 1.9. Now let's do that analysis. And let's see what the LC match tells us here. Aha. So I can either put a series shunt, a source shunt, it's bouncing around a little bit here, and in series, 884 nanohenries, just below 1 microhenry. So here's a couple of different configurations: source shunt, series, load shunt, and I can actually take a snapshot and put it in the Smith chart, which is what I would do. I'd grab the S1P right here. I do storage. I'd store the S1P right there like that. And then I export that to the Smith chart and then do serious analysis. And it'll tell me, you know, give me tons of information of which I can play with all day long. But for a quick analysis, you can see some analysis of recommended L and C network. Oh, I see. It's going back and forth between 2 different settings here, or 2 different solutions. So hopefully that answered your question.
Yeah, so by hooking it up and going through the whatever frequency I'm going to, it's going to give me the solution for that frequency.
Correct.
Okay, and so all I gotta do is match what it says on VNA by just pushing the buttons, on my function buttons.
That's it on your LDG. That's all you'd have to do is dial in that into that particular configuration. I don't know. Your LDG is either a T network or an L network.
SL.
So let me give you another interesting tip.
Mhm.
Something I figured out a couple of weeks ago was that on L-match networks, there's 4 different configurations for that, right? You can either be a high pass or low pass, and then that series component can either be towards the radio or it can be towards the antenna side of the node connecting the 3 components. All right.
All right.
Well, with 2 double pole, double throw switches, you can actually modify and rewire any L network tuner to be able to be a 4-way compatible. So if you get a better match and lower L and C component values, which will give you less losses, using it one way than the other, you can quickly just switch across between those two switches, one of 4 conditions will give you a match. You can immediately see the match on your Nano VNA, and then bang, you've got full control of your whole tuner system.
Well, I have a follow-up because I know that Wes also owns for the field some buddy poles. So what's just speak about that, because in the buddy poles you have those little taps and stuff. So maybe that tells them where to put the taps or how to tune it.
Yeah. Well, yeah. I mean, of course, I do have an analyzer I take out in the field with my ass, but this here might be a little quicker.
So if you've got a buddy pole, a dipole with a pair of matching ham sticks on there, then typical tuning is to change the position of the stingers. And obviously you want them at the same length on both sides. And you can get a ruler.
Hold on. It's not, let's just get clear. He doesn't have ham sticks.
Yeah.
But his buddy pole has a coil with taps on it and a stinger.
Right.
Okay.
Little bit different than what I have.
Got it. All right. So what you would do then is, if you've got fixed taps, some of them have fixed tap points where you can have a plug that goes into it, then you'd have to use one of those. If you can clip it to any one of the coils, then you could literally look on your Nano VNA for the band that you're operating for the frequency, and literally touch on different coils around that and actually see your SWR change and the actual impedance matching right on your Nano VNA instantly, and know which coil exactly is the best one to use.
Yeah, this by running on a tap. Yeah, okay. I think I know what you're talking about there. Yeah, because I've done that. I just didn't know I did it.
Exactly.
Yeah. Okay. All right. That's what I do. I just when I run the tap on the coils, I got a book, but it's a close proximity. You know what I mean? And so I'll set it up. I'll count the coils down or from the whip end, and depending on what circumstances I'm using it in, I may have to do it from the other side of the coil, so to speak. And but either way, it says it depending on I get a solution. I just, like I said, this here might be a little quicker. It might be to get me on the mark a little quicker because it takes time. Because that thing's up in the air. You know what I mean? So I got pulling it down and pulling it up, so it just got. I think it might be a better option. This is how much again?
The Nano VNA.
Yeah.
Like I said, the El Cheapos are started around 60, and this guy is kind of the deluxe version. It's about 120, 130.
Okay. All right. Yeah. Now, that being said, now if I had my antenna in the air, can I can just hook that right to my coax?
Yeah, actually, absolutely. You could. This is a PL2 or SO239. This is SMA. Everything on this unit is SMA. So you get an adapter to whatever coax you have, and go for it.
Yeah. Okay. So I get two options for my antennas. Like I said, I do have buddy poles, which I have 2 of them, one large, one small, and the other one is a portable. I want to be able to take this portable with me next summer and play with it more. I haven't used it in about 4 years. It works well, but it could be a real problem tuning it,
Right.
So, but Chris, like I said, my main field is a G5 RV Junior 40 through 6,
Right.
up there in 40 feet. So I'd hook that up to the cable coax itself, I think,
Right.
to get a better read on the frequency.
Right. So something to keep in mind that's really important is once you actually calibrate your Nano VNA up to the calibration plane where it meets the antenna, the physical wire of the antenna itself, it's the equivalent of putting the Nano VNA right there, even though you're down on the ground. So all you have to do is calibrate that once, hook it all up, shove your antenna up in the air, see how it does, and you can actually analyze it in situ. Then you can bring it down and maybe try a different tap. But once you know where that tap is, it's going to be the same place, the same way
All
every time.
Yeah, got it. Right. Okay, well, that makes things go out simpler. Well, thank you, Rudy. Appreciate the information.
My pleasure.
Okay, so let's see. We had a question that came in on the text, and hopefully the gentleman is still here. There's a question about who asked this question. Hang on a second. It was David KJ K7DMJ. He wants to know about it. Maybe you can unmute yourself, David. He want to know about connectors. Is that an SMA on that end, and what does he need
Correct.
to go? So
Yeah,
that little connector, that little can you show on your, I don't know where your video is. It's a little messed up there. Can you show the
my phone battery finally crapped out, Barry. Sorry.
Tell us in the on your picture earlier, you had you had what looked like an SMA to a SO239. Is that little connector come with it, or is that that adapter or not?
That's an adapter. That's an aftermarket adapter. The only thing that comes with what does come with it are SMA female to female and SMA male to male, so that you can do through testing with that. So I don't know if you can see this on the other camera.
Pull it back. It's a little too close to the camera. Yeah, there we go. So that's probably for people that have a regular PL259. The one end that he's holding is the SO239, which is what you'd plug the standard PL259 into. That's what most people have. Yep. He's showing it on the other end. You have to push it. You have to hold it farther away from the camera. There we go. So in point to the one to the PL259 with the little male piece there. Yeah, on the left one. That's what's usually on people's
Barry,
black.
your face is showing, not his.
Oh, sorry.
It's all right.
Sorry, I talk and I see his. So let me put. Thank you.
Hey, Derek.
Hey, Rudy.
Thanks. Now I spotlighted. What happens is when I'm talking, it shows up on mine, but not yours. Now you're good. Okay, thanks, Derek. So
this is Rob, NZ6J.
Yeah, Rob.
Yeah, just to throw in a couple of things from my experience. The SMA connectors are fragile. In fact, they say that SMA connectors are limited to only 100 connections and disconnections, although that may be an urban legend. There's two things you can do to protect your Nano VNA. The first one is to use a male-female SMA adapter. You buy those $6 a pair off Amazon, and you just hard tighten the connection onto the Nano VNA, so you've got a protected adapter, so that if you screw things up, you throw that away and buy another one rather than throw away your Nano VNA. That's the first thing. The second thing is the Nano VNAs are so small, they tend to get moved around as your cable moves. And what I've found successful is to use tails rather than rigid adapters. In other words, a tail that has a male SMA on one end and a SO239 on the other, with just about a couple of inches of coax, and you can buy those off Amazon as well.
Yeah,
so that's and the last thing I want to comment on, the Nano VNA actually is surprisingly good in terms of comparing it with professional products. Like I've got access to a Keysight analyzer. The results are almost identical as long as you're not dealing with large dynamic ranges. So in other words, you saw there where Rudy was showing the SWR, when it was above about 2 or 3, then there was a lot of noise in there. And that's your dynamic range coming into it, because the Nano VNA doesn't have much dynamic range. But that doesn't matter. If all you're looking for is the sweet spot, then the Nano VNA is going to give you almost identical results to a $30,000 professional product. Thanks a lot, Rudy. Great presentation.
Thank you so much, and great comments. I would agree with all of those. To have a sacrificial connector on your Nano VNA is a really good idea.
Yeah.
thanks, Rob. Appreciate it. Who else has a question either about this or generalized ham questions? We all got time. We got 21 of us still on. Just open your mic and give your call sign.
So Barry, I'm looking at some of the chat, some of the questions here. Sierra Echo asks, how much is the PC card with different setups for the Smith chart and where to buy it? So if you're talking about that little demo board, this guy here, if you're talking about the demo board, that's I think that costs like 25 bucks, something like that, maybe less, maybe 15 bucks off of eBay. eBay's got all of this stuff. Just like one of these little kits, this comes in a kit form. Okay, this is the little through connector prototype where you can, I put some little headers on here so that I can plug in capacitors and home wound inductors, stuff like that. Plug it right in here and make little LC circuits, matching networks. And I put it with my cables as a through circuit into the Nano VNA, and I do the analysis that way. That was, I think, like 12 or 15 bucks, maybe $9. I think it's pretty cheap on eBay. Let's see what we get. What other questions I'm looking for here? Well, any other questions before
Yeah, I
we
think
wrap
Bob
up?
NZ6G out of Truckee had his mic open earlier. Bob, do you want to come on and ask your question?
Yeah, this is Bob NZ6G in Truckee. Yeah, first of all, Rudy, really appreciate this. This has been nice. Just to confirm something, I occasionally build some antennas and stick them up in the air and fiddle around with them. And just to confirm, let's say I'm building a Yagi and I get my initial reading without any balance or stuff like that. Well, with the balun on it is, it's the Z comes up with a fairly significant plus J piece of the impedance. Now, if I were to stick, for example, a gamma match on that, which would add capacitance, and just tune that thing until I get a pure resistance reading on the impedance, is, say, using a Nano VNA or some other device. Is that the appropriate approach is that an appropriate approach to tuning an antenna?
Wow, great question. I'll try to give you the Cliff Note version answer, but the real answer is probably best handled in a seminar. We can really go into it because it's pretty detailed. What you're really looking for is you're trying to match two things. You're trying to make the resistance value of your impedance, the real value, the R value, close to 50 ohms or whatever your feed line is. And you're trying to make the J value as close to 0 as possible.
Yes.
If it's above the horizontal on the Smith chart, then your antenna is typically has inductive reactance.
Yes.
And
Yes.
that means it's too short. And vice versa, if it's below, it's capacitive and you need to add an inductor to it. Now, how much to add? Boy, that's a whole discussion of.
Well, no, I'm just saying an average. I mean, it would make the appropriate way to go about it would be to lengthen or either lengthen or shorten the elements.
Right.
But will you get for a given resonant frequency that you want to work at? So
right.
that's and sort of sticking a capacitor or a variable capacitor or a variable inductor up there next to the antenna is kind of, I guess, cheating a little bit.
Well, no, it's actually what the mobile guys do all day long with screwdriver antennas.
Well, yeah, but there's a loss there, isn't there, in terms of how much of your power actually gets. Everything's
a trade-off. So yeah, the more inductance or capacitance you add, the more loss you have.
Okay, so that's what that's been my belief, but I wanted to hear somebody else that knows a little bit more about, or knows a lot more about this than I do.
The first thing you want to do is get as much antenna wire length as possible. Okay, even if it's not resonant, the longer the wire you can get out there, the better. That means you'll have to use lower value capacitors and inductors to get it into resonance when you do that.
Yes. I mean, all the books talk about, for example, putting a gamma match up there to add capacitance and all that. And it's like, it just looked to me like you're going to lose. I don't know what percentage of your wattage that hits the antenna you're going to lose that way, but I'm trying to do it with nothing but a balun to deal with how you talked about baluns earlier, you know, just to get rid of the coax as part of your antenna.
Right. Well, that would be a current choke that does that.
Or, well, yeah, current choke, yeah.
Yeah, that's what I'm using. To get rid of it.
Yeah.
That's all.
Okay. Thanks.
You're welcome.
Yeah. Hey, I'm famous.
We still have 20 people on here. Any more questions for Rudy or anything about general ham radio or SNARS? You've got plenty of people on. Ask away.
Oh, by the way, while we're waiting for another question, the two pieces of software, free download, are Nano VNA-QT as in Quebec Tango and Nano VNA-Saver. You can play with both of those. They're both pretty good. They're a little bit different. Some people like one over the other, but they're both available for download.
And the important thing about those programs, Rudy, is that it gives you a very professional printout of your measurements. So it's very hard for anyone looking at the printout to tell that you've got a $60 analyzer to make the measurements. They look so good.
Yeah, exactly. Does a good job.
Difference on, say, just generally speaking, the more introductory $60 range versus, say, the $125, $150 range. Yeah, VNA.
Well, I would say number one, battery, ruggedness of the case, number of data points that it captures, and the resolution and size and resolution of the screen are the main factors that determine the price of these things for the most part. Some of them may have a little bit less dynamic range than others. You'd have to really dig into the specs on it, but you kind of get what you pay for at the end of the day, as always. And so this thing, like I said, I sold my MFJ 259B for twice this price on eBay. And so I could have bought two of these things. So it was a heck of a bargain for something that was 10 times as powerful. So even getting the deluxe version was a deal for me.
And I think having 3 gigs doesn't hurt if you're trying to muck around with Wi-Fi antennas and stuff. You've got a tool that nobody else has.
Oh, yeah. And by the way, speaking of Wi-Fi antennas, I'll give you guys a tip. I don't know if you're aware of this or not, but did you realize that there's a Chinese version of the SMA connectors that's reverse sex? In other words, what we have as a pin on the male side, that's got a thread that threads over the top of a female. That threaded side that's showing you a male thread has got a little female socket in the middle. The Chinese version that's called RP, reverse polarity, will have a pin there, and the socket will be in the cap size with the internal thread. So watch out for that, because I got a Chinese Wi-Fi antenna that I couldn't figure out why it wasn't working. And it was a reverse polarity type connector. Once I did that, I got an adapter for it, and it worked great.
Well, Rudy, it's not just Chinese products. Even the American-made Wi-Fi routers have RP-SMA on them. So if you've got an antenna sticking out the back of your router, it'll almost certainly be RP-SMA, regardless of where it's made.
Interesting.
Yeah, that's what I found. Same thing.
Good to know. Anyway,
some of the ham radio HTs, like in the DMR world, and I always get which one is which. Some are reverse SMA, some are not. It depends how they make them, at least on the radios and matching antennas.
Yeah,
But
so you just got to watch out for that.
Reverse pinning, you're talking about the threading being either male or female. I don't think that.
No, the pin. The pin and socket.
The pin too, yeah.
Yeah,
Really?
the pin's reverse. Yeah.
Really?
Oh, yeah.
The thing is reversed. So I have one radio that has SMA. So for instance, the anytones are reverse. I'm looking at one right now. The anytones are reverse of what the I don't know which one it is. One of them is reversed.
Okay, I got it right here.
That's really scary.
Let's get, wait a second. Let me get you're on here.
Yeah, as a matter of fact, it
Go
is
ahead and
scary
show it now, Wes. Which one is
because
which?
if you get this wrong and you've got an open there and you put a lot of power, you can blow your final.
Which one is which at West, you know?
Okay, this here is inward. So you got to have a pin going into the middle. This one here is outward, a pin coming out of this.
And they both have a male thread on the outside of that.
Correct.
Yeah, that'll really screw with your head.
No, one's on the outside and one's on the inside. Flip it back around.
Yeah,
Wes.
the pin, yeah. This here's is hollow. The others, the pin goes inside this. You're like we're right on. You know what I mean?
Oh, so that's a matching set of reverse polarity.
Yeah.
And on my 1HT, I have the equivalent of what's in his left hand, and my other HT, well, the opposite side. My other HT is the opposite. So they're just the gender's reverse is all it is.
Gender's reversed, and the threading is one goes over, one goes in.
Yeah, so it's just Is Rob? Is that what you're talking about?
Sorry, what was that?
Is that what you're talking about? The different plugs?
Yeah, well, as I said, I think that's just on Wi-Fi equipment that I've seen it. I've never seen it on ham equipment, but
they have them both ways depending which radio it is. Yeah.
Right.
Yeah, I think what you guys are mixing up a little bit is the gender on top of the radio being either male or female. That the reverse polarity that Rob's talking about is done on all the Wi-Fi equipment, so you can't. Most normal people can't add extra antenna size to a Wi-Fi router, which will violate the regulations.
Well, don't tell them. Well, yeah, that was good. Thanks for the information.
We got 18 people still on. Some people must want something other than just hanging around.
So
What
here's
other
a question.
questions do you have?
Here's a question for the remaining group. Barry and I have been talking about putting together a series of workshops that actually get into real hands-on messing around with Smith charts, antenna design, matching circuits, L network, prototyping, building, testing, tuning, the whole 9 yards. So if there are enough people interested in participating in that, then I'd be willing to work on putting together the first of that, which would be a fundamentals course to lay the foundation, and then we could take it from there. How many of you guys would be interested in participating in something like that?
It's hard to say, time-wise.
Are you thinking of Reno or Truckee?
Probably down here.
Thought we were talking about Zoom instead, not in person.
Yeah, well, we would do it
Are
by
you
Zoom.
talking about, okay, hold on one second. Are you talking about the workshop or are you talking about the antenna shootout? Which are you talking about, Rudy?
Well, I'd probably start with a Zoom workshop. That's the easiest
Okay,
for
a Zoom
everybody.
workshop is Zoom.
Right,
I think we're talking about Zoom, Rob.
right. Now,
Okay.
if beyond that, we get to actual hardware, we're literally bringing antennas and bringing analyzers and capacitors and inductors and winding coils and crap like that. That could be a lot of fun. That's a hands-on workshop.
Right.
We'd probably want to do that in person.
Yeah, exactly.
Yeah.
I would assume maybe, I don't know. We'll have to see when we do it, probably in spring when the weather's a little nicer. And I'm assuming maybe down here, but it all depends.
Rudy, can I just add something? This is Rob, NZ6K.
Sure.
One of the cool advantages of the Nano VNA is determining crystal frequencies. So if you've got a box of crystals that you can't tell what frequency they're on, you just connect them up to the do S11 measurements with them, and voila, you can find the resonance frequency instantly.
Yeah, that's a very cool thing. You can measure inductors and capacitors the same way. Yeah, it's a really handy tool. It's my Swiss Army knife for antennas.
Yeah, good. For sure. Yeah.
Well, to give you an idea on the value of this Nano VNA, a few years ago, and we're not, maybe 10 years ago, about the least expensive VNA you could get your hands on new was about $10,000.
Mm-hmm.
And they went up to about 100-something thousand. Then an outfit came out with one that plugged into your computer for about 900. And that was really thought to be quite a breakthrough. And then these nanos showed up, and every ham should have one.
Yeah, if you know what you're doing with it.
That's correct. That's what
I think it's pretty straightforward. For if you're doing SWR measurements, I think it's really a good tool for even people who don't want to go deeper.
Aspects of it you can use. You don't need it all.
Yeah.
If you only use the SWR function, it pays for itself.
Exactly.
Mm-hmm.
Can I also mention the Tiny SA? Have you played with those, Rudy?
Yes, I just got one a couple of weeks ago, and I've been having a lot of fun with it.
The Tiny SA, interestingly, while it's made in China, it's actually designed in Holland, I think it's Holland, somewhere in Western Europe. And the guy who designed it is just incredible. He responds on the chat on the forum all the time, and the Tiny SA is actually turning out to be a beautiful match for the Nano VNA, and they look like cousins.
Yeah, it's a good match. It'll actually let you do analysis. It comes with an antenna. You can actually look at the spectrum. It's like a spectrum scope. It is a spectrum scope, and it just doesn't have the waterfall. And you can really see harmonics and splatter, overtones, RFI, all kinds of stuff like that. That's what it's good for.
Yeah,
The worst thing is
I've got one, and I recently have started seeing this 1 hertz noise being picked up by my antennas that I don't think was here like 2 weeks ago. And I'm thinking about going around the neighborhood and with that and seeing if I can find some kind of a local source. I don't know if it's local or not. It's pretty strong and it's pretty invasive, affecting my usage quite a bit. So, if it's just some kind of seasonal thing, I don't know, maybe it is. But if it's some neighbor, like I have a neighbor with a electric fence, and those sometimes do that kind of thing. She's had it for a while, but anyway, I'm thinking about using it for that.
a DF tool, huh?
Yeah.
Well, how many units is it coming up on your radio?
Well, let's see. Let me just make sure it's calibrated here. It's coming up to 3 or 4 S units pulses.
Yeah.
One
what
hertz.
Frequency?
1 hertz. No, it's a wideband frequency, but pulsing at 1 hertz.
Oh, okay.
That it's definitely man-made, right? That's not natural.
What frequency is it at?
I don't know, but it's at all the ham bands, especially the lower ham bands, the HF bands that I work.
Sounds like the electric fence, man, because that's what they do. They pulse.
Right. So I'm gonna go check out her electric fence because she had some issues before, with it being disconnected at her gate, accidentally. And I saw that and I warned her about it and she fixed it. But I didn't notice any issues from her fence, but it might be something else. So I thought I'd go around the neighborhood with it, with the antenna, and see if I could see anything,
Yeah. The only problem with the Tiny SA is it's not really calibrated above about 300 megs, which means you can't pick up the third harmonic of your Baofeng. So when you key up your Baofeng on 146 megs, you're transmitting on exactly 3 times that frequency as well. And the Tiny SA doesn't really cover the third harmonic with any accuracy.
Hey, Rudy.
Yes.
Do they have any of those VNAs they hook up to a computer, a laptop?
Well, yeah, that's what we're saying. It comes with a USB-C cable plugs into a standard USB port, and Nano VNA QT and Nano VNA Saver, free downloads. You load it into your PC or Mac and plug in your Nano VNA, and off you go.
Cool. You know, yeah, top and bottom bifocals. So
Yep. Yeah. So Barry, you wanna tell us about, I'm big on this current choke thing. I think a current choke can solve a lot of people's problems very quickly, very cheaply, and make a huge difference on the usability of their antenna system. So if you're still there, Barry, tell us a little bit.
I can talk about it, although I didn't put it in the right place. So do you have one there you can show what it looks like?
Yeah. Well, I've got.
So
This here is, it's what's called an FT for ferrite toroid 240, which just means that it's 2.4 inches OD, and it's a -31 material. So that's the mixture of the ferrite material that's used. And this is what you typically use, either a 43 or a 31 material for winding chokes and balance. This is a miniature version. This is a 114-31 that I wound a balun, a four-way switchable balun. So instead of the TRB, this is a QRB, a quad ratio balun. But it's just a miniature version of the 31 material. And it's they're pretty easy to wind. In fact, what's really cool about the 240 is you can take a coax with two PL259 on it and literally turn 6 turns one way, then you bring it back down through the other, and you do 6 turns the other way, and then it comes out on either end, and you got a PL259 on one end, and you got your coax on the other end, and you literally stick it up onto your antenna, and it's isolated your feed line from your antenna, and you won't get RF in the shack, and you get you can move the coax around, wiggle it all you want, grab it, etc., and it don't care.
I've got one of those on each of my antenna lines coming in the house. Exactly that. I don't even have them in a box. I haven't tested it, but I read online somewhere that that it's okay to have it outside. It doesn't even need to be protected from the weather or anything. I don't know if that's true or not, but that's what I read. And it's like Rudy said, it's very easy to do. And, those things cost about $10 right now. But the 240 ones, but like you said, you can run a PL259 through there. I've got eight or 10 turns on mine. I think that's supposed to be a good ratio for most of the HF bands for blocking stuff. And I don't think I have any, RF coming in the shack. I haven't seen any signs of it.
Barry,
yeah, I have several of these made up. This one happens to be
there you go,
plugged in, very simple to put together. Also, for the power cable coming in, same sort of thing to keep the noise out of it. About half the weight of my station is ferrites all over things.
I got bags of them over here.
It's the toroids are great. The new materials, the 43, and the 43 is good for the low bands, 160 and 80 typically, and the upper bands favors the 31 material a little bit more. But you can use either one on 160 through 10 meters pretty easily. They'll do a good job across all pretty wide band.
Yeah. This is what I use on the Buddy pole.
TRB.
Yeah, it's a TRB, right?
Yeah, I wound that, and I ended up winding a QRB. That's this little guy here. This is actually the guts winding of a quad ratio balun. Based on the diagram that the guy who built the TRB actually has online. Right. So I just followed that.
said, man, tell you what, this little gizmo works pretty good. It really does. I mean, I tell you what, I have made a mistake. I was playing with some other stuff out in the field with the same antenna, and I come back and I couldn't understand why my SWR was so damn high. And it's just, I remember I says last time I had the thing out, I was using really long antennas on the ends of the coils, and it was set up for 4-to-1. And I pulled it down and switched it over to 1-to-1. Tuned up, no problem. But,
Cool.
Is that a what the TRB, is that a 2 or 3 ratio
Triple.
balance?
it's
Triple.
triple. Yeah, 4-to-1, 2-to-1, and 1-to-1.
Okay.
Quick minute. I want finish your conversation, Derek, and then I want Rudy to explain something in a minute. Go ahead.
Well, no, I just want to know, he flashed it up on the screen. I just want to know what it was. I hadn't seen it before.
Yes.
So he explained. Thanks, Wes.
There's a switch
Well.
there. But I want Rudy, because you and I talked ad nauseum on my issues. Can you just explain again, so it's clear, the difference between the impedance balun versus the current choke balun? Because I was unclear of that, and that was a pretty cool thing. So
Okay.
we're clear on that.
No problem. So a current choke, in comparison to a balun, a current choke isolates your feed line from anything else downstream from that. And it's a transformer laying on its side, okay, with the coils in the horizontal, so to speak. So the input at the top is your center conductor, and at the lower left would be your ground on your coax, and the upper right and lower right would be the center feed and ground of the output of that sucker. So that's why you can just wind a PL259 type coax onto that and have a PL259 on either end, and you're good to go. A balun can be either 1-to-1 or some other ratio. And that's basically a voltage balun. So the current balun is usually called a guanella. You'll also see it referred to as a guanella, Gaunella, guanella. That's AKA current balun. The Ruthroff or voltage balun is a traditional transformer. So you're putting the input across the primary and you're taking the output across the secondary. And the ratio of the number of turns of the secondary to the primary determines whether it's a 4-to-1, 9-to-1, or a 1-to-4 or a 1-to-9, whether you're going up in resistance or down in resistance. You'd go up in resistance if your antenna is longer than natural resonance. You'd be going down in ratio, less than 1, if your antenna physical length is less than its natural resonant length. And so for short antennas, you'd be using like a 1-to-4, not a 4-to-1. You with me, Barry?
Yep.
Hey, 1-to-4.
1-to-2, 1-to-4, 1-to-3.729, whatever you want to wind.
Okay, I got you. All right.
If your antenna's 12.5 ohms, you want 50, if you want a 4-to-1.
Yeah, or 1-to-4 actually.
1-to-4. Yeah, I mean, yeah, right. You want to reverse what you would normally think of, using a 4-to-1 for.
Exactly.
Yeah.
Most people think of balun ratios because they have an extra long antenna, like a end-fed half wave. Classically, you've got like a 9-to-1, or I've seen 36-to-1, I've seen 49s-to-1 for really, really extreme situations. But that'll be more lossy. 9-to-1 is pretty typical.
Yeah, I'm using 49-to-1 on my SOTA antennas, and it seems to be giving me pretty good match.
49-to-1.
Yeah, it's the ratio is 7-to-1, the turns ratio, but as Rudy mentioned earlier, the impedance ratio is the square of that.
Correct.
Gotcha.
So somebody asked, Whiskey 7 Lima Romeo asked, wants to learn more about balance and chokes. Any good books and references? If you Google balance and current chokes, there's a bunch of really great articles, but probably the best ones I can recommend are by a guy named Seebick, Charlie Echo Bravo India Kilo, who's SK now, unfortunately. And the other one is by Roy Llewellyn, who's been writing articles for ARRL QST for forever and a day. And hang on a second, there was another one in here. Let me just take a look real quick.
Put in K9YC wrote a bunch of stuff. I put the piece on there, and he has a bunch of stuff there too. I think, but I'm not positive, ARRL publishes or sells a book on it. But some of these are just available online.
Well, they have
got a lot of good stuff.
They have a good section in their antenna compendium. But yeah, there's a bunch of good articles on there.
When you're looking that up, we've been going over an hour. If there's more chat, we can continue. If it's just hanging around, I'd like to end, but we're happy to stick around if we're still talking. So just kind of want to presence that. Hey Barry, do you want to tell the guys a little bit about our stealth antenna project? I'll let you mention that, because you talked about it a little bit when on the last Zoom call and that homebrew thing. I think that might be an interesting thing to talk about. So Barry, I think you live down here. You live in an apartment on upper floor, right? And you have a balcony, I assume. So, and he's not alone. There's a lot of people out there with restricted spaces, either physically restricted or deed restricted, HOA restricted, etc. I've been doing a lot of modeling using EasyNet and SimSmith, and I really sympathize for those people who are restricted like Barry. So I've come up with and I've built already and tested a copper foil zigzag dipole. And in 8.5 feet of a strip of acetate, 8 inches wide, I've made a dipole in 8.5 feet that is resonant beautifully, naturally resonant on 20 meters, which would otherwise be 33 feet long, right? So I've taken that now to the next step, and I'm making a multi-band 10 through 40 meter copper foil plastic American flag that you can hang proudly off the end of your balcony. What do you guys think of that idea?
That works.
I think it's excellent.
Booyah.
No HOA could bitch about that.
I think that's a very American thing to do.
Exactly. You salute that flag and you don't know it's an antenna, and you just challenge and dare them to the antenna Nazis out there. What are they going to say?
Right.
I'm curious from a practical perspective, if you can talk just for a minute about this. If it's blowing in the wind, depending on how you create it, what happens to the both SWR and the pattern out in the
the pattern might wiggle around, but you know what I'm going to do is I'll have a couple pieces of PVC tubing slipped into a loop at the base that will keep it straight and keep it hanging fairly straight, even though it'll be still pretty light. And that way, kind of like drapes, right? You'd hold drapes straight at the bottom. Same kind of concept. I'm still playing with it. It's just a crap load of fun, but I just like giving the middle finger to all of these antenna Nazis.
I'm with you on that. I do agree with that concern that Barry mentioned. I have a vertical that's basically a half of a fan dipole, and it works great. But when we get wind, SWR can really vary a lot, and it triggers my auto tuner. So I have to tune it and then turn off the auto and turn it to semi-auto so it doesn't automatically start tuning, because that actually blew the finals on my FTDX10.
Oh, wow.
And I just got it back like a week ago or something, but it actually blew the finals on not so much because the SWR varied itself. I don't think that in itself did it. I think it's because it triggered the auto tuner to start doing a full tuning cycle, and that's what actually blew my finals. The FTDX10 is protected from that supposedly, so they fixed it on warranty. It still cost me $125 to ship it to them, but
Yeah.
wow. But the warning is, if you do use something like that, be aware of that possibility. And my suggestion is, either don't use an auto tuner or auto tune and then turn it on to semi-auto or something, so it doesn't tune on you frequently.
Right. That's a good point. Well, this is a living experiment, so I'm gonna mess with it and keep you guys informed as to what I learn. But anyway, I just think, a lot of people need a lot of help in terms of trying to figure out how to get on the air on HF from restricted spaces. And I've seen some really, really goofy things. Like there's this one that's basically a long wire, and then a guy sticks a big rod in the ground, and he's got this big heavy duty, what looks like a transformer. I'm sure it's like a 49-to-1 balun or something like that, that he just at the base of it. And it's not very stealthy, okay? It's the long wire. It's not very compact. So it's a real challenge to try to do. So I'm trying to figure creative ways to solve that problem practically. So I'm making the antenna out of, I found a plastic American flag shower curtain. So that's what I'm building it on.
Rudy, this is Howie, WB2AWQ. Have
Hey,
you
Howie.
modeled the efficiency of that antenna?
Well, I actually modeled it on EasyNeck. So I looked at the launch angles. I looked at the efficiency. I'm still looking at a whole bunch of stuff, and I've looked at several different ways, including spiral antennas, using the Petlowany or however you pronounce his name. I forgot his spiral concept, but using it as the main dipole, not as end resonators on the end of a boom, but actually as a resonator, full resonators themselves. But I found out that a zigzag serpentine fashion back and forth like ribbon candy with copper foil tape, 1/4 inch to 1/2 inch wide, seems to do real well, especially if you round out the turns. Sharp edges, it doesn't like sharp edges, so you got to round the turns out, because those are going to be high voltage dissipation points anyway, especially towards the end of the antenna, of course. So efficiency wise, I got to really get out there and measure this and see how it works. I'm just getting some equipment. I've got a power meter coming, a digital power meter, and a few other things coming. And we'll see, but proof will be in the pudding, but it sure is going to be fun as hell to play with.
Very good. I had to leave during part of the presentation, but I came back and lo and behold, it's still on, which I thought it was very interesting. And I live in an HOA situation. I have 10 antennas up for basically all bands 80 through 10.
So what are you
and
using?
I'm always looking for ways to improve the efficiency of what I got. So between the Nano VNA, which I think is a neat tool, you've opened my eyes to that, and I'd be interested in seeing what you come up with on the whatever you call it, the flagpole antenna.
Yeah, American flag. So yeah, that'd be great. What is your best performing antenna? What's that look like there on your HOA?
Well, okay. First off, I'm a firm believer in single band antennas. The idea of the 43-foot wire is a compromise to my way of thinking. So every one of my antennas is single band resonant. I have the dipole on a fence for 80 and 40. That's two separate elements. I have another dipole on another fence for 10, 15, and 20. I have mag loops for 20, 17, 15, 10 meters. And I also have a half-wave end fed, which is actually my best performing antenna overall. That's for 40 meters.
Well, cool. Yeah, I would tend to agree with you. If you've got the room for the lower band, full length dipoles, single band dipoles, I would say absolutely go for that.
Yeah, I fully agree with that. And I understand where you're coming from with the aiming actually for the more limited people than I am.
So, but I also believe that people tend to be they like a set it and forget it multi-band antenna. I believe.
Yeah, I'm not that way. I love to play with antennas.
Yeah. Well, when you're working SOTA or POTA, unless you're out there for an antenna field day, messing with antennas specifically, and you just want to make some contacts and you don't know which band's opening up or closing down, it's sure nice not to have to drag your buddy pole down every time just to change that tap. So I'm developing for some solutions for that. But this thing's that I'm building is a multi-bander, and so it's we'll see how I suspect what I'm going to end up having to do is probably put like a triple or a quad ratio balun in a little box with a little rotary switch on it, and you might have to pull it in off the balcony and flip the switch and for changing the bands, and that's about it. And that'll get you into the killing zone of your auto tuner in your radio.
Very interesting. Very interesting. Be curious to hear how that goes.
Yeah, I'm curious too.
By the way, Rudy, I am the editor of the SNARS newsletter. When you get that figured out, or even before, boy, if you'd love to send me an article, I'd be more than thrilled to publish it.
Oh, that'd be fun. I'd like that. Yeah, I got a lot of work to do, and I got some mileage to put under my belt here to get it to where I want to be. But it'll be an interesting story to talk about the development of this thing if it actually goes somewhere.
Yeah, it could actually be a work in progress series. It could be even a series of articles too. It could be a work in progress kind of thing.
Ah, that's an interesting idea. I'll keep that in mind. I'd love to do it.
Yeah, I'd love to publish it.
Great, that'd be fun.
Anything else before we call this a wrap by anybody? A great conversation, Dave, Rudy. Thank you.
So much. one other question, Rudy, before we go, what I did miss was I assume you touched on what's the best Nano VNA to buy, and I missed that part. If that was covered.
Mine.
Yours.
It's the Dash F version 2, V2.
Okay. Do they make that with regular coax connectors like SO239s? Because I'm not a big fan of these mini connectors. I think they're kind of a weak point.
This thing has got a a tank of a case on it. It's a really, really solid aluminum case. So I don't think the SMAs are going to come loose. All right. So there's no threat of loosening up from the PC board. What I would do is just get yourself an adapter to, BNC or UHF, whatever you like, and stick it on your Nano VNA and you're done.
Also, Howie, it was mentioned earlier, you can buy, instead of just a small adapter, you can buy a pigtail where one end.
Yeah,
is an SMA.
that would take the stress off the connector. That's true.
Somebody mentioned it earlier in the chat, which I can get and send to you. They said you can buy 2 of them for like $6.80 on Amazon.
Those kind of things are very cheap on Amazon. That's for sure.
I bought one for $14.95 at HRO when I was there in person one day this summer. So yeah. And the advantage of the pigtail is you have a little more dexterity. But yeah,
and it takes the strain off the adapter.
Right.
Yes, very good.
I have one.
Yeah, you can get 2 of them for $6.80 on Amazon.
Yeah.
Free one-day delivery.
Thank you, Rudy.
Yeah,
my pleasure.
Yeah, that's Derek too. I have a question for you on those single band antennas in your HOA. Where are they in relation to seeing them, and how skinny is the wire, and how do you stealth it if you do it?
You're addressing that to me, Barry?
Yes. Howie.
Okay.
Yes.
2 of my fan dipoles are on fences, so they really can't be seen from the other side of the fence.
What about people in back of you?
People they could see them, but my property is fairly deep. My property is about 180 feet deep. The NFET, I have 2 NFET antennas, one for 40 meters. That's strictly a 40-meter antenna because I use a tuned circuit at the base of it. The other one is a multi-band antenna. That's for 15 and 30 meters. Those are made with number 26 magnet wire. And they're about, one is 14 feet high, and one is about 11 feet high. And I work a lot at DX, and I'm not a big DXer.
Get on for sweepstakes this weekend?
I may get on. I like the sweepstakes. I like to pick around the edges and see what's there.
So I'll throw in one more offhand thing I've found recently is I'm looking at doing some poto work in the near future once I get this all worked out. And I picked up what's called a DOCA pole, DOCA. I don't know if you guys have ever heard of it, but they use it for window washing and changing light bulbs in high ceilings in churches and stuff like that. And they have them up to like 31 feet, 5 or 6 sections of 6 feet each section. And they're positive locking, which is nice. It's not a twist lock. These things have a locking lever on each section.
What are they made from, Rudy?
Aluminum, and it's really, really nice. Yeah, I know you're going to say, what about lightning storms? It's just called take it down when the weather gets bad. But
no, I was thinking more about the some of the crappy pole type antennas are made from
PVC.
I'm trying to think of the material, but it's semiconductive.
Okay.
And it can pose problems if you're trying to use it as a vertical antenna, that sort of thing.
Oh yeah, right. No, I wouldn't use it as a radiating element. But what I found is really cool is they have this thing that I just got, by the way. I don't know if the camera's still up. You can see this. It's what's called a Flagpole Buddy. Can you guys see that?
Yeah, that's what is that?
What this is, it's really cool. This is meant, you mount this, clamp this to like the ladder of your RV, for example. And it's got a, you put your mast, you put your antenna up and you extend it, right? and it's got a little clip on the side. So you hold it 45 degrees, shove it into the jaws of this thing, and then you turn your antenna vertical, and it's like two hands grabbing it, one from either side, grabbing your pole, and it's got it in a death grip, and it's really, really cool.
That's neat. That's very neat.
So
What's
it's
it called? It's hard. It was hard to see. Can you bring it
Oh,
up on the
sure.
screen share? Or I'll bring it up. What's it called?
Yeah, hold on a second. Let me see if I can get some better lighting on here. It's
You have
called,
to push it a little farther away too.
can you guys see that now?
Yeah.
Okay.
Push it a little farther away, Rudy.
A little what?
A little farther away.
A little lower too. There you go.
Yeah. Okay.
Okay, so it's called the Flagpole Buddy. And you see this thing? So basically, this is like your right hand, and this is like your left hand hooking in. And then these are the clamps that go onto a piece of tubing. So I'm going to use a piece of tubing on the side of the house with some antenna brackets. But your pole goes in sideways, and then you straighten out your pole, and the two hands kind of clamp onto it and grab the pole, and then your mast is in the death grip.
So where did you get that, Rudy?
Amazon, $60.
Called Flagpole Buddy.
Yep.
Okay, I'm gonna bring it up on the screen and see if this is the same.
Oh yeah,
Let's see
it's really cool.
see if this is the same thing. Is this what we're looking at, Rudy?
Uh,
Or is this something else?
yeah, that's it. That's the thing.
So
You can
is this
see
what
how
it looks like right here.
Yeah, exactly. You can see where it's clamped at the top of that pipe. Yeah, you can see what I'm talking about.
How do you pull it down? It just flips
No,
down.
you just you just twist it out of that. You would twist the top towards you, towards the viewer, okay, and then pull it away from the RV.
Show a little video here real quick. Let me bring this back up. I think, let me just try this video real quick.
I find that to be real useful. You know, even at the house, at the home QTH, you can hook
Right.
this up, get your mast up and going really solidly, really quick, and put it up and take it down
Try
real
this
quick.
video for a second, see if this shows us something.
Quick and dirty. Yeah, cool.
Huh.
That's it.
That's really cool.
Yeah,
It's two different clips. It just holds it. That's very cool.
yeah, it's a cool giz for quick portability for something really solid. It's better than a tripod.
As long as you have something like an RV or something to hold it onto.
Yeah, or you mount a piece of antenna mast pipe, the short 1 foot section with a couple of antenna mast side clamps for a regular TV antenna. Put that under the eaves of your house, and you just clip that in and just set the bottom on the ground or on the concrete or whatever, and your mast is up and it ain't going anywhere.
Is that made out of plastic?
It is, and it's like a real heavy duty ABS,
FRP, yeah.
FRP, ABS, something like that.
That's really cool. That's very cool.
Yeah, it's great for, this guy's got Wi-Fi antennas and cell phone booster antennas, but hey, for the Doka pole, it's perfect.
But how do you spell Doka pole? DOKA?
DOCA. And one of the things I've done is I've come up with a couple ways to attach PVC cross and pipes and stuff like that to the top of the Doka pole. So I've built some
This
rigged
is
up
the
some
Doka pole here?
adapters. Yeah, that's it. And you can see that's got
interesting the way they flip up like that.
Yeah, they've got those flip up levers and they work really well. They're really solid.
Rudy, you said that you would hesitate to use that as an actual antenna. I'm curious to why. Is it the aluminum is not positive contacting?
Well,
It makes sense.
yeah, I don't think that this section to section conductivity is really designed for that.
Okay.
Now,
Well, I would imagine that the section to section would not be conductive because of the plastic.
Well, the plastic is just a clamp. I haven't really tried it. It might be. It's an interesting idea. I haven't thought about it. You could even tune your antenna that way, which is really pretty cool. But, you know, now that I think about it, I'm going to try that. I get the Nano VNA on it. Load it up.
There you go. There you go.
Yeah, I mean, if you were doing a wire antenna, like a long wire or something, I think it'd work fine. You know, I think lightning might be an issue, but
Yeah.
but you'd want to have a ground rod or something if it was at your house, right there, and ground all the sections somehow. You probably could use cable clamps or something to do that. But but I mean, you know, if you're going to do a vertical, you know, wire alongside it, I think it would affect the vertical wire quite a bit. I don't know how much it might make it directional. It might, I don't know what it would do, but it definitely would affect a vertical
Yeah.
wire.
You know,
If you're doing a horizontal wire, I don't think it's, you know, or reasonably horizontal wire, because I use
Aluminum, or what's it made out of?
yeah, it's aluminum.
They're right here. It says
This
aluminum.
is a great way to get up an inverted V.
Yeah,
says
yeah,
it's
it would
high
work for
quality
that.
aluminum telescopic pole.
yeah, it would work for that.
And I can tell you guys, I did a lot of research on all kinds of mast and extension poles, and this is the best design for the money. And I've seen stuff that was $300, $400 from DX Engineering and elsewhere that was nowhere near as well designed and implemented as this. These little clamps are really solid.
That's pretty good. $80 for a you know, 24-foot pole.
Yeah, that's the one I bought. I think I paid $60, $69 for mine.
Very good.
The real trick, the real trick is getting the adapter from that funky broom handle thread. That is, just so you guys know, that's a 3/4 by 5 TPI thread, which is really funky. And but I've got adapters for that. I'll show you one. If I can,
Let me bring this down.
if I can dig it. Hey, here we go. All right, you guys see that? So
It looks almost like a hose nozzle.
oh, sort of, but it's not. It's broom handle. So there's a female broom handle adapter, okay? And I drilled and tapped a 3/8 24 thread into here. And I'm gonna get some just threaded rod studs to put in here, and then put a female, one of those big long female threaded nuts on here. And then I'll have a female base for my broom handle, for the end of my Doka pole, so I can have verticals on there.
That is nice.
If you guys hang on a second, I'll go grab mine. I'll show you what I did, just for shits and grins. Hang on.
What do you think makes the Doka pole the Doka pole? Those little Howie, those little up and down pieces.
The clamps, you mean?
Yeah.
I don't know. It's a neat idea. If the sections make contact, you know, that would be could be a good thing. Certainly a temporary thing you can put up at night and take it down before you're done operating.
What's interesting about it is it may be, when you push it up and down, assuming it's you know, not resonant, but conductive. Maybe as you go up and down, it's going to change the length of the antenna. Maybe.
Well, yes, absolutely, it would. If it's conductive between the sections.
Well, you could use some hose clamps or something with some braid, maybe.
Yeah.
You know, and it put a hose clamp on each section and connect.
And if it's not conductive between the sections,
Yeah.
using it as a support for an antenna is really a good thing. And actually, even using it as a support for an antenna, even if it is conductive, that may affect the antenna small, but it's probably not going to affect it a whole lot because it's at the center of the feed point.
If you're doing an inverted V or something, I don't think it's going to be a big problem.
Right.
I think if you were going to put it up permanently, you'd want some kind of protection from lightning, though.
Absolutely.
And that's where I would use braid.
Yeah.
If you're just doing it temporarily, I wouldn't worry about it because just take it down during lightning.
Exactly. So you guys see that?
What's
Yep.
the white thing on the, I see the other
Oh.
thing is a dipole
It's
connector.
it's my homebrew PVC adapter.
Okay.
Uh-huh.
So basically, this is a 1-inch PVC adapter. It's a cross, and I drilled a 3/24 threaded hole as a set screw, and I can put a vertical on here. And these guys are for pieces of PVC 1/2-inch tubing, 5 feet long each, on which I'm going to hang a pair of American flags. This is a dipole mount here. This metal cross. Here's a CB Trucker's windshield or mirror mount for a double antenna, and I just reversed the connectors on one, and so I've got a like a buddy pole type dipole mount
Yeah, that's cool.
on the end of this guy. But
Nice.
I really like these. I really like these clamps. These swing up, and this comes out really easy, and then locks in place. Boom, and then it's got a death grip on it.
Well, yeah, they have a lot of strength if they're, using brushes on that. It's got to be tight. So yeah, that makes sense.
Anyway, I think it's the coolest thing.
Right. Have you tried taking a volt-o-meter or anything and see if there's any connectivity between the different sections?
I haven't checked it yet. So
Is it anodized?
I suspect it is. It's probably anodized or allodyne.
So that's that. Well, if it's allodyne is conductive, anodizing is not.
Right.
Yeah, iridite's conductive too, but it would be gold.
Yeah, well, allodyne is also called iridite sometimes.
Well, I used iridite years ago.
Yeah, I used it. We used it at work a lot.
Yeah, and it it made non-conductive aluminum pieces conductive when we had noise.
So one of the other cool things I did is I stick the base of this through a tripod. That's a Radio Shack antenna or a roof apex mount type antenna base tripod. Okay, and that holds it up vertically. And then I put this right above it, sits on top of the tripod. And off to the sides, I've got a couple of pieces of PVC tubing onto which I've mounted a couple of small 10-watt solar panels. So I can just take this and rotate it around and point the solar panels and twist them up and down, okay, and point it at the sun, sitting there, just rotating, and then I lock it with a couple of screws here in place, and now I've got my solar panels that keep my battery charged, and I've got 20 watts of solar, which matches up to my G90 just fine.
Interesting. Very interesting. Well, thank you, Rudy. That was really a good presentation.
Well, thank you. Barry and I did a lot of work on that.
And thank you, Barry, for setting it up with him. That's really good.
Yeah, thanks, Rudy.
My pleasure.
My pleasure. By the way, for the coming up to the 2 weeks from Monday, if I have the right date, the next Snars Ham Radio Night, one of the rooms I decided was we're going to do homebrew again. And so if you, Rudy, or other people want to come and share some more cool stuff, that's one of the rooms. I think it's homebrew is very cool.
Great. Well, thanks for setting this up, Barry. I really appreciate it.
My pleasure. I think we're going to call this a wrap. We've been on for 3 hours from the beginning. Thank you so much, everyone. And thank you for your contribution, Rudy.
Happy to help. It was a lot of fun, actually.
We'll get the recordings onto next week onto the YouTube website, and then you guys can all see it. Have a great
Barry?
Saturday, everyone.
Hey, Barry, before you go, have you captured the Q&As, the results?
I have all. I don't know what they are until I look at later, but yes, we have it there.
You've captured them. If you can get a chance and send me the Q&As, the before and after Q&A results, I'd love to see those.
I'll pull those reports up after it.
Perfect.
Yeah.
Thank you, sir.
Okay. Have a great afternoon. Maybe see you on the air, Howie, later.
Have a great time. Have a great weekend, guys.
Barry, only if you're on CW.
All
What
right,
I'm doing.
see ya.
Okay, 73.